Hi everyone, and welcome to my talk from IDP to AIDP, evolving your platform for the machine learning age. My name is Körbächer. I'm the founder and managing director of Liquid Reply, and also help customers to go through a platform engineering journey and learn how to build platform as a product. Now, the big question for today is AI the new frontier? And if we look back into the past, and looking into which discussion we had around the platform of Kubernetes running different kind of workload than just a stateless application, we can look into a decade of debate about stateful workload, about databases, about far edge deployments, and so on and so forth. I believe actually we don't need to discuss this nowadays anymore. I think it's solved for most of the part. But if we look in today, we need to adjust to AI and to come along with AI development and facing new integrations. But why we're doing this is more about looking into the future where we have to become AI native. Also, we do not like to talk so much about AI nowadays and feel more annoyed hearing about it every day and night and every corner, every conference. It's reality in some way. And that's why we are actually here talking about and discussing about how we can move your IDP to an AIDP. But first, does it needs to be Kubernetes? Well, no, it doesn't needs to be Kubernetes. It can be on bare metal servers and it actually would be more efficient, but you can also run Kubernetes on bare metal, right? Researchers prefer also notebooks. Not the notebook which you carry around in your backpack, but a notebook for working on your models, for your research, putting together your notes, algorithms, and data and whatsoever. And they can run also everywhere, and they actually run very well in, I don't know, things like a Juniper harp. And they can run again on like VMs. And then we have specialized machine learning platforms like Hugging Face, right? And last but not least, obviously, we have cloud AI services that manage away a lot of the complexity around it. But still, as we talk about platform engineering, and again, not every platform needs to be in Kubernetes, but Kubernetes has a pretty solid environment and ecosystem that you can use for all of that different challenges we will look at in the next minutes. So, looking into this whole landscape of machine learning and AI and data, which is beside the cloud native computing foundation out there, is insane. And this is what it also makes so complicated to build actually just easy peasy new platform for serving AI, because the landscape here is incredible large with commercial solutions, with managed SaaS solutions, with managed provider solutions, and so on and so forth. But you have the same thing mirrored entirely into the open source. Yeah, sure, we have this also in our day-to-day cloud native environment, but in AI, as it is a current hype in the end, this landscape is developing very, very fast from day to day. So our big target is to bridge the gap between the regular developer to research team, to machine learning engineers, to data engineers that have the purpose in the end to deliver a product that have AI or Gen AI integrated. And we look here into some few different things that are going to different direction when you look into the persona itself. We look into the developer who are looking to code first approach, have small artifacts, yay artifacts like microservices are needed everywhere, predictable CI/CD, we have auto testing, and so on and so forth. You know all the story. But looking into machine learning and AI researchers and engineers, we are more on experimentation first approach. Now that doesn't sound so big different, but an experimentation is a wide, huge field. It can be just minor changes on some labeled data. It can be some fast training on something, building here and there some rack or chain up a new data source. And suddenly you have tons of new data which you have to process and so on and so forth. So the complexity of the flows, um, not just like is similar to what we have on the regular development of an application. In my opinion, it's more like double or triple complicated. And because of the fast moving market, it become more and more complicated. So When we're looking into the infrastructure, what's needed? Well, I always like to start more with the performance monitoring or monitoring itself. Because if I know what's going on, I know how to fix things very fast and where to search it. While often monitoring comes at last. But to understand, for example, the GPU utilization can help you to make your platform being more optimized towards the workload you actually have worked with. Because also not every company, for example, does model training. They most of the time mean that they use RAG. And yes, it fine tunes and it trains in some way a model, but it's not like building an entire new model on a dataset, right? Resource sharing, wow, that's perfect for Kubernetes because that's where we all feel comfortable with. And you have solutions around it for single or multi-tenant CUDA, for time slicing, MIG, and virtual GPUs, and dynamic resource allocation. But the most exciting one is Kai, because it just recently got published and open sourced after NVIDIA has acquired Run AI. And Kai is specialized on managing all these resources and the different AI models which you want to use. So, no problem here. Scheduling? Come on, nothing easier than that. You have QE, Kubeflow, Volcano, and so on that can use and implement for large data sets, for large training, I don't know how to say it, actions, timelines, to bring them up and help to schedule them throughout the day, throughout your platforms, throughout your resources, and put them on point. And last but not least, we talk about hardware access. And I think this is in some way the most easiest. It's more a question about what you can use out of this hardware. But I almost know no real AI related hardware that it's not really supported in a Kubernetes ecospace. So I think we are very, very good here. Looking into some other corner around the whole story, we need to think about a few things that comes on top. Yes, data is an old thing. We have dealt with data in the past, but I think we do not understand how much data we actually talk about if we talk about AI and machine learning. And yes, we need to differentiate absolutely between, do I train a full model and need petabyte of data to train it, or just do I make some rack fine-tuning training, which can be a few hundred megabytes to gigabytes to terabytes and so on. Nevertheless, data is like the lifeblood for AI. And at some point in time, you have to deal with the question, where does it come from? Where do I store it? How do we understand and make visible that there are changes in data sets? And how do we ensure that we, for example, have enough capacities to work actively on this data? Because only if you, not only, but in the best case, you have clean data, and then you need data engineers that are working throughout a huge chunk of data, and they sometimes do chunk updates. They bulk updates. Update a whole set of information over terabytes of data, and then you need a very performant solution for that one. And then you have to distribute all this data too. And so data becomes with the AI movement again a very new thing, new quote unquote, to think about in a different way. Because we cannot just now say like, stateless workload, blah blah blah. In some way, a model is kind of stateless, but until it reaches this point, it needs tons of data. And when it has reached this point and you load a model, a very large model, into a GPU, it still has a ton of data which comes with it and eat up all the virtual memory for solving that in the end. So, in addition to that, GenAI and AI inferencing comes on top. Now, especially today, we often mix AI and GenAI. It's two different things. GenAI is just like the part where we generate things out of commands or talk to it, like ChatGPT, Midjourney, whatsoever. However, this is what we nowadays most of the time understand, at least on the customer side, when we talk about AI. To deliver GenAI or provide inferencing capabilities, you have tons of options out there. That's not a big challenge. But we need to still think about like how to put it into our landscape and how to allow our platform to enable users in the end to really utilize the AI inferencing and have just an easy process to bring up a new model. So we need to change our mindset. I would say almost again, not thinking like an IDP is for developers. No, we need to build products, we need to build IDPs that treat models as a first class citizen, and they come with their family that are developers, that are data engineers, that are machine learning engineers, and so on and so forth. And this makes the whole life cycle very complicated, which we have to take a look at. That's why we have this infinite loop, which is infinitely connected to other loops. And we have to go through all of these processes and help to provide that in the end to the user of an AIDP. So we need to democratize the AI development process, leverage, for example, self-service portals, allow them to simple manage what they want to deploy where, which models are currently out there, which data sources available, and plug and play those things together, not to have like a shady backroom server running where you log in and put some stuff on it. But it also brings the possibility to show and teach more about cost visibility, for example. We can provide here environment templates. So either a whole pre-configured machine learning stack, or even like for notebook environments, bringing up entire pre-configured notebooks like Jupyter. And then we need to come with a whole integration layer too. We're talking about MCP and A2A protocols for integrating either with other tools or with other agents. But where do you know which agent is available and which agent you can use? So, evolving our platform, I think the path which was so far most, I would say, successful, which we have seen so far, is like start with the basics, go with the GPU enablement, go with good storage management, and help with scheduling and scheduling large data processing. And from there, you can go into put into your platform machine learning toolings, help to provide a simple inferencing service like with VLLM or Kserve. So you can put into a Backstage, for example, just a service where you can create a simple YAML file, point out to which model you would like to serve, have Kserve running somewhere on the platform, trigger that whole thing, deploy the model, and then have a simple integration with a UI to access this model and work with it. Um, then we need to talk about the integration part for CI/CD, for monitoring, and also registries. And last but not least, we also need to consider that we have a continuous ongoing innovation. AI API gateways are now coming up. Like in Envoy, we have seen a lot of development. MCP servers are coming up. And we have tons of other stuff which we don't talk today about, but maybe tomorrow. So what we can do on the reference architecture side to make our life easier, and this is a very hard part. Also, we love our reference architecture here. The question is like how we can move on, how we go maybe beyond even the IDP. Because as we have seen in the beginning, the AI ecosystem is very complex. And that's also our largest problem. A complex ecosystem, integration landscape that's moving fast, and external dependencies which is out of our control. To bake this into our reference is the biggest question. And then we have to measure also the success at the same time as we leading into AI-ready IDPs, because we have to take a look into also like how is the model serving going on? Do we penetrate some guardrails? Do we have some PII leaks? Or how does the performance of the platform looks like? Because performance will drive adoption. And I think the best argument where we can invest into this is that an AIDP, the evolvement from an IDP for being a first nation citizen for AI, is that we can enable organizations also to become ISO 42001 compliant. Because it just asks practically to be 100% sure of what and where you use AI. Now, this is not solving every problem, but at least for the professional part, With an AIDP, you have this control and can implement this control. And with that, my takeaways: connect your development teams with the machine learning engineers. Data models, resource enablement is the key to go. No fancy services, just get the basics done. Think about AIDPs as a product. Iterate and measure what matters so that you don't go and run into the wrong decision. Don't take uninformed decisions. And last but not least, an AIDP can be an enabler for regulations. Thank you very much. Hope you had some fun, learned something new, and looking forward to meet you somewhere else.